Discussions about introducing new technology are just mind-blowing. Sometimes I read about something new and I go like, what a brilliant idea! Why didn't we think of this before? However, for this certain technology, my feelings were a bit mixed. Imagine going into space through an elevator. Imagine the height you would go up to. Now imagine how scary that would be, and just imagine how impossible it seems. Space is at a distance of 100 kilometers from Earth's sea level, and imagine an elevator that is 100 kilometers long. Isn't that totally mind-blowing and confusing? I mean, how the hell is that even possible? How will they even support it? How will they make sure that it's safe or that it's even durable? Well, you know our scientists, once they think of something, they definitely execute it, and I have a feeling that this elevator will be part of our bright future. So, what will this space elevator look like? I'm sure you're dying to know. But before I reveal the facts that are going to blow your mind, quickly subscribe to this channel, give it a thumbs up, and follow for more interesting videos. So, coming back to my promise, assuming that you have already subscribed, here's how the elevator will look. Drum roll, please. The major element would be a cable, otherwise a tether, which will be attached to the ground and extended into space. Just imagine that our lives will be dependent on a single cable. Scary, isn't it? Believe it or not, but this might prove to be very useful. Where once we had to use large rockets, this structure will enable vehicles to traverse the cable instantly into orbit from a planetary surface, such as Earth's. The space elevator's best benefit will be its capability to send off payloads and astronauts into space for a much cheaper price as compared to rockets. Moreover, it would enable us to develop spaceships and space stations in orbit instead of assembling every one of their parts on the planet and then sending them off into space using heavy rockets, which are very costly. However, there are still discussions going related to the material that will be used to build this elevator and whether that material will be durable or not. An Earth-based space elevator could not simply be a tall tower supported from below because of the monstrous weight. Rather, it would comprise of a link with one end joined to the surface close to the equator and the opposite end connected to a stabilizer in a space beyond geostationary circles, which is 35,786 kilometers in height. The contending powers of gravity, which is stronger at the lower end, and the vertical diffuse power, which is stronger at the upper end, would bring about a link being held up, under tension, and fixed over a solitary position on planet Earth. With the cable deployed, climbers could more than once move all over the tie or link by mechanical means, delivering their cargo to and from the orbit, thus giving another place to call our second home. The development of a space elevator would require a decrease of some technical risk. A few advances in engineering, manufacturing, and physical technology are required. Once a first space lift is fabricated, all the others would have the utilization of the past ones to aid development, making their expenses significantly lower. Such follow-on space elevators would likewise profit from the extraordinary decrease in technical risk accomplished by the development of the first space elevator. Prior to the work by Edwards in 2000, most ideas for building a space elevator had the cable manufactured in space. This was believed to be important for an enormous and long object involving such a huge counterweight. Making the cable in space will be done in principle by using an asteroid or near-Earth object for source material. These previous ideas for development require enormous pre-existing spacefaring foundations to move an asteroid into its required circle around Earth. They likewise required the improvement of technologies for manufacture in space of huge amounts of exacting materials. However, there are certain risks attached to this space elevator as well. A space lift would introduce a navigational hazard, both to airplanes and also rockets. Airplanes could be redirected via aviation authority restrictions. All objects in stable orbits that have perigee underneath the maximum elevation of the cable that are not synchronous with the cable would affect the cable at some point. One potential arrangement, proposed by Edwards, is to utilize a portable anchor, sort of like an ocean anchor, to permit the cable to avoid any space debris sufficiently big enough to track. Influences by space objects, for example meteorites, micrometeorites, and orbiting man-made debris pose another constraint on the cable. A cable would need to be designed in such a way that it avoids the debris on its way and it sustains the impact of small debris without breaking. Let's hope for the plans to actually work, so maybe our next vacation spot could be space itself. And this, my friends, is all we have for today's video. Thank you so much for watching. Take care.